Alrighty then. So we're gonna have we need to have two screens. So you're going to have this is for this was a substitute Thursday, Friday. There was really nothing to turn in. So I'm going to leave that assignment there, and that's where you're going to turn your stuff in. But I need to go back over here to the other side, and this is not a mid-app inventor. I need to move these around. Hold on. Move these over here. Nope, I don't want it to open up. Please don't. Thank you. No, please don't open up. All right. So on this side, I need to take you to... we got bolts going on here, and we need to go to PLTW over here. So www.pltw.org. Okay, I'm showing you how to do this. It's not because I'm trying to, waste time or whatever, but I'm trying to help those who have not done this before or in a while. You're going to log in. If you need your logins, you go back to Google Classroom and get your login. Okay. All right, classes, core classes. Down here to computer science for innovators and makers. Okay, you're going to go down here to the ins and outs. And we're going to go get 2.3. Get connected. All right. So the first thing I said again was to make sure you had all your supplies. Make sure you have your hex downloaded. And so I'm going to go through this with you, what you're supposed to be doing. So I've talked to you about the digital dive stuff. We talked about that there's going to be two tables. One's going to be able to talk back and forth. But this is, according to the legend, 10th century Viking king Harald Blatand peacefully united several Danish tribes to form one kingdom. His last name, Blatand, I guess, I don't know, translates in English to Bluetooth. So in 1997, a new wireless technology was developed connecting many digital devices. The developer thought that King Harald Bluetooth would have been pleased to see mobile computers and cell phones united by simplifying how they communicate with each other. The new technology was named Bluetooth because it connected many digital devices, much like King Harald Bluetooth's uniting of the Danish tribes. Even the Bluetooth icon and logo you see on computers and smartphones today is a combination of King Harald Bluetooth's initials in the Old Norse alphabet and an ancient language. Which is an ancient language. Blah. Today, Bluetooth wireless technology uses a standard radio signal to send packets of data from one digital device to another. The signal that Bluetooth technology uses is 2.4 gigahertz shortwave radio frequency, so it doesn't travel long distances. This is perfect, though, when you want to listen to some music through headphones connected wirelessly to your nearby smartphone. Excuse me. So on the back here, you're going to see here's your Bluetooth antenna, and it goes right here, and this is your Bluetooth antenna. Okay. So your microbit may have a compass and accelerometer sensors combined as a motion sensor that can perform both functions. So take a look at the back of your microbit. So everybody should have their kits. Microbit. Okay, there's your microbit. All right, so this antenna, like I said, is a Bluetooth low energy antenna. It's an antenna used to create a personal area network that uses low energy to power Bluetooth wireless technology. So find the label, BLE antenna. It may be difficult to see because it mostly consists of wires inside the microbit. BLE antennas use less power than standard Bluetooth antennas. These low energy antennas are great for microcontrollers because then you only need 2 AA batteries, 3 volt power to the microbit. So to activate the BLE antenna in your programs, you'll use code blocks from the radio drawer. All right, so let's go to our other side over here, and let's go ahead and let's go find our make code for our microbit. Oh, nope, I did that last time. I apologize. Maker code for microbit. All right, so we're going to just do a new project. We're going to open it up and we're going to just look at things today. Well, we might do more than that. But you see down here, see this little antenna looking thing? Well, this is your, like, down here at the bottom, okay? That tells you how much of signal that's coming in. So you're going to click on that drawer. All right, so you see it's similar to what's on the left. Here's my radio send value. There's everything you need right here. So let's look through it all the way down to the bottom, okay? All right, so there's that one. Okay, so as you may know, a math equation can include variables. Using these variables are unknown values. So a value is a numerical amount defined in an algebraic equation, or numbers represented by letters of the alphabet. So let's take a closer look at the different types of variables used to store data in programs. All right, so I'm going to go ahead and open this up, and I'm going to play this video for you so that everybody doesn't have to go anywhere else to find this video. All right, I'm going to go ahead and play the video, and I'll be back when it's finished.
Have you ever wondered how a video or computer game keeps score? Or how the thermostat at your house stores the temperature setting you choose? Computer programs use something called variables to store information they need while the programs are being used. You may be familiar with the term variables from your math class, but variables in computing are very different from variables in math. In this video, we'll explore computing variables. Computing variables are placeholders in the computer's memory that can temporarily store a value. Each variable has a name and a value. Think of a storage box that holds and stores papers, and each paper in the box contains information. A variable is like the storage box. It's a container that holds and stores information. The values inside a variable can change just like the contents of the box. Variables can hold different types of information, also known as the data type of a variable. For example, a variable can store a number data type, or a text data type, also known as a string, or a logic data type, also known as a Boolean data type. Let's first explore the number data type variables. A good example to consider is how a game uses a variable to keep score. It's important to give your variables descriptive names so it's easy to understand what the variable is used for in your program. So let's call this variable score. It's best practice to initialize every variable that you plan to use in your program. To initialize means to set the starting value. Some games start players off with 3 lives, so 3 would be the initial variable value. Game scores usually begin at 0, so in our example, 0 is the initial value for this variable. Every time you earn a point in the game, the value of the variable is updated to keep track of your score. When a number variable is updated to a larger value, it is said to increment. The value increases by a set amount or increment. Let's visualize the game score example in a slightly different way. The first line of code x equals 0 initializes variable x to be 0. The second line of code x equals x plus 1 initializes variable x to be a new value. The new value is equal to the current value of x plus 1. The current value is 0, so the new value will be 1. If it continues to increment from the current value of 1, the new value will be 2. Number variables can also decrement, or update to a lower value. For example, in a game, this might occur if the game takes points off your score whenever you run into an obstacle. Now let's consider an example of the text data type variable. Some games ask for the player's name before you can start. Because the name changes based on who's playing the game, This information needs to be stored as a text variable. Let's call this example variable player name. What if you want the game to say hello to each player after they enter their name? You can program the message to join the text stored in the player name variable with the string hello to say, "Hello, Raquel." Variables can hold a lot of useful information in a program. They make programs a lot more flexible and reusable.
All right, so we talked about variables now. There are 3 types of variables. We talked about the values. The value one is a numerical amount defined in algebraic equation. A string. My goodness, Facebook, go away. A string is a sequence of characters, letters, numerals, symbols, and punctuation marks. And the Boolean, and they call it Boolean, but it's Boolean, a type of data in computing that a logical expression evaluates to. The only possible values for Boolean are true and false. So in this activity, you're going to use variables to store strings and numbers. So one data type that a variable can store is a string, which is made up of sequences of characters like letters. In the following code example, the variable x equals a string of characters that spell the phrase "Hello World." What do you think the str means in this example code? So I'm going to tell you it means string because str is right there. Sometimes they use those kind of things to help you out by just giving you shortened versions. Because if you had to write every word out, it would be longer than long and you couldn't do anything with it. So another way to use strings is to set a variable equal to the length of a string. You can also show the length of a string on the microbit LED grid using a length of string code block from the text drawer found under Advanced. All right, so what numbers do you think will be shown on the microbits LED grid when the following program runs? All right, so why don't you try it out? Try it out, figure it out, find out what it does. Okay, and it's not the emulator that you're going to use. You're going to be using your microbit. Use your microbit. All right, here's a calculation. I need you to be able to do this calculation, and then I want to see when you do it on your on the make code, I want to be able to see your screenshot of the make code that you do. I want to see this. I want you to try this. On button A pressed, set an A and all this, and I want you to try it and see what it does on the microbit. So in this program you're going to see 2 groups of code. These groups are called event handlers. All right, event handlers, a block of code that is triggered when a certain event happens. So this means that the first group of code triggers an event and the second event handler executes the event or action. All right, so this is your first one. This executes the code, and this says what it does. All right, so after the first event handler computes the value of x, the radio code block sends the value from the variable x as the answer to another microbit. So let's say, if you remember the map that we used, let's say you use that. You went from that particular bus, where the bus was. Okay, that was where we started. That's your first event handler. Then when you got to the museum, that was your answer. So your first event handler computes the value of x, and the radio code block sends the value for x as the answer to another microbit. So there's how you get from your bus was one, where at the school was the first one, the first event handler, and then the other one was the museum. All right. So what do you think will appear on the LED grid of the receiving microbit when it gets the data packet from the sending microbit? All right. So they want you to try it out. So you need to find somebody. You're going to have a pair, And so both pairs need to have a microbit. In those kits, there are still more microbits. So the ones that I have, I don't know if I hope I didn't put them back inside. Everything should be over there in that corner where your microbit kits are. Everything should be there. Okay, so now this, you're going to download, you're going to import your math hex. How do I import? Okay, let me go ahead and go here, and I need to open up this, my maker code. Okay, and so now I'm going to go back out to my home. Nope. I know it doesn't have a name. So what? Done. We're just going to call it Untitled. We're not going to worry about it. Okay, so I'm back out here. So remember, I'm going to import a project. I click Import. I import my file. I choose my file. And it's not going to come up for me because I'm not hooked up to the VPN. But you'll have your box with your files. You're going to find this hex file, a2_3_math.hex. And you're going to click go ahead and go for it that way. I don't know why it won't let me out. Oh, there it goes. Oh, it let me finally. Oh, no, it's not going to let me. Okay, so let's say that this was my file. Okay, this was my hex file. So I would click on it and I would open it up, and then, excuse me, it will come back here and I'll say, okay, go ahead. And then it will be located here, and it usually will open, but it will be called the same thing, a2_3 math hex file. All right. So once you get that in the emulator, I would like for you to go through at least bare minimum to where it says code tracing a variable. Go up to that point and stop and put whatever information you've done. If it's something you need to explain to me, give it to me on a Google Doc and just turn it in. I need screenshots today. I want to go back and I want to reiterate, I need screenshots today of what you've done. So let's say you've done, you've looked in here into your, and found the BLE, found the drawers. I want to see the screenshots of you finding the drawers. I want to see a screenshot of anything that you've done here. If you've done the program, what this one, what number do you think will show? Put it in a Google Doc. Any questions? Put it in a Google Doc. Do this calculation. Give me a screenshot of this that you've built in MakeCode, and go from there. And do anything that it tells you to do. If it tells you to show, or, like, okay, here's the value of X on 4. It wants you to put in the value of X. So what you're going to do is you're going to go to your Google Doc. You're going to put down number 4 and put your value in there. Okay, so I want you to go just to number 5 today. All right, have a great day and do your best. Miss J out.